Okay, we're going to work today on multiplying positive and negative integers. There are three ideas that we absolutely need to emphasize, that students need to understand prior to being able to use the method I'm about to show. And that is that multiplication is about groups. Okay, so for example, 3 times 4, which the students will already know because here we are in 5th, 6th, 7th grade. We're doing multiplication of positive, negative integers. This they've been doing since 1st grade. And so they'd have to interpret this, and you'd have to remind them that this is 3 groups of 4. Or some people will say 3's in the group and you have 4 groups. But I'm going to use the idea of this being 3 groups of 4. So 4 is in each group. You could use the other model if you like. The second thing is the prior knowledge, and that's kind of getting into what we just talked about now. So this is 3 times 4, 3 groups of 4, and that they understand what this means. The third thing is the opposite, and this might be something that we have to work on for a little bit. And so the opposite, for example, if you have positive 5, the opposite of positive 5 is negative 5, or the opposite of 5 is negative 5. You might have to do a little bit of work with this too, because if we have just the number 5, which is positive 5, we could look at this as being the opposite of 5, which in fact is also negative 5. So there's two ways to kind of look at that minus sign. It could be the opposite of 5, which is negative 5, or it could just be negative 5. Okay, we can also look at it as being, if I have a negative 5, if I want the opposite of negative 5, so now here, this is being the opposite of negative 5, that would be positive 5. But this idea, both of these ideas are essential in order to use the method that I'm showing here. Okay, so let's build off of their prior knowledge, and their prior knowledge deals with, of course, multiplication. We talked about the grouping idea. I might begin with 3 times 4 again, a problem they've seen since 1st grade, and ask them, how would I write this in terms of the positive, negative integers that we have been studying recently? Okay, so kind of translating that body of knowledge into this new system of pluses and minuses. Okay, and so what we really want them to be able to tell us is that this is the same thing as this right here. Positive 3 times positive 4, because these are both positive numbers. Okay, that we can write a positive number like this or like this. This is where you might introduce the idea of the parentheses, in that a lot of times at this level it becomes necessary to write this as either positive 3 times positive 4 or positive 3 times 4, or whatever variation you want to use there. This is a good place to introduce the need for the parentheses, because we're having two signs right next to each other. Gets kind of confusing. So this is where we can get rid of the times sign and just put the parentheses there. Makes it a little bit cleaner. Anyway, now their body of knowledge of multiplying two positive integers, actually for them would have been multiplying two whole numbers, that whole body of knowledge translates into this new system of positive integers, that we just are going to write them a little bit different ways. But we could write it like this, we could write it like this, and so on. Okay, so now we've got them multiplying positive integers. You know, they're just reinterpreting what they've been doing for maybe 5 or 6 years. Okay, and again, to represent that, if we were using yellows as being positives, we could represent this positive 2, for example, times positive 3 would be 2 groups of 3 positives. Okay, and I see 6 positives. Okay, or I could say 2 groups of positive 3, and I could go to a semi-concrete model. So there's a group of 3 positives. There's a group of 3 positives. I see I've got 6 positives. Okay, so now on to something to build another area of their knowledge with positive negatives, and that is to maybe challenge them to say, okay, then what would this mean? Okay, so in terms of the groups and the ideas, it would be like, okay, I've got 3 groups, and each group are 4 negatives. So if the blue represent negatives, I could have the students physically show me in the concrete 3 groups of 4 negatives. Okay, and I can see that the answer is negative 12. 12 negatives, or 3 groups of 4 negatives. There's 1 group, there's 2, and there's 3. And I can say I've got 12 negatives. Okay, now here I'm going to begin to collect my data. So there's one problem I have on the board. I could have the students show me positive 2 times a negative 3. They could use the concrete, the semi-concrete. They could even just think about this, 2 groups of 3 negatives. And just do it completely abstractly, and that's fine too. Depends on, just let them do it. You let them do it however they'd like to do it. And then positive 5 times negative 2, negative 10. Okay, so you write these 3, maybe a 4th one on the board, and what you want the students to do is to take a look at them and see if they could find a way to solve these problems without using the semi-concrete or the concrete items. Can they figure out a way to come up with this answer based upon this question, so to speak? And of course the idea is, okay, well I can see 5 times 2, 2 times 3, that'll give me the number, and the answer is always going to be negative. Okay, so then we could just go ahead and test it out. Three groups of 5 negatives. Oh, by the way, testing out, in other words, they would have said 3 times 5 is 15 and negative. So they would have first tried it, and then they would have checked it here, which is what I'm doing here. So they do it, and they say, okay, based upon our pattern here that we found, it looks like it should be 3 times 5 is 15 and a negative 15. And then they check it out, and sure enough, it works either here or here. Okay, so that's one thing. When they have a positive times a negative, you get a negative answer, and you just get and you just multiply the numbers. Okay, so far so good. Now we're going to bring in the idea of the opposite. So this opposite idea. So let's just take a look at the number 12 and decompose it in terms of 3 times 4. Or positive 12 is positive 3 times positive 4. It doesn't really matter which one you use. Now, if I ask them what's the opposite of 12, they would, of course, tell me negative 12. Okay, so they should be familiar again with that part of this. Well, if 12 can be written as 3 times 4, if the opposite 12 is written this way, how would I write the opposite of 12 in terms of 3 times 4? And so the students shouldn't have too much difficulty saying, well, that's the opposite of 3 times 4. Okay? And so we could try again with like the number 8. If I'd say, okay, 8 equals 4 times 2. If I want the opposite of 8, I could write that as the opposite of 4 times 2. And maybe generate a third one. Negative 15 equals negative 3 times 5. Okay, so we've got this piece of information, and this piece of information, and this piece of information. And by the way, I can reverse these too. I could say, well, then if negative 15 equals negative 3 times 5, then negative 3 times 5 equals negative 15. Negative 4 times 2 equals negative 8. And negative 3 times 4 equals negative 12. So looking at this information I've collected on my board, I could ask them, okay, could you have found the answer here? Negative 8 just from here? Can you develop a rule that would give me -8 if I had -4 times 2 without using the counters or the idea of the opposite or the semi-concrete drawings? And again, it's not very difficult to say you just multiply the numbers and the answer is negative. So if I'm multiplying a negative times a positive, I get a negative, and you just multiply the numbers. So we would test it out. Again, negative 2 times 3, and they're saying, based upon their rule, they're telling me the answer should be -6. It's the first time they've ever done multiplied a negative times a positive in the abstract, and then they could check it out. In other words, it'd be the opposite of 2 times 3. Since 2 times 3 is 6, the opposite of 6 is -6. All right, so now we found a second rule. Before we had a positive times a negative equals a negative. Now we have a negative times a positive equals a negative. So we have two different rules here. One if the first number is positive and the second's negative, or one if the first number is negative and the second number is positive. And now I could ask them, geez, could you look at this and tell me an even more general rule? Do you see something that applies to both of these where you don't have to worry about if one's the first one or one's the second one, if the positive is first? And the idea is anytime you multiply a positive and a negative, whether it's positive times negative or negative times positive, you get a negative number. And that's, of course, the general rule that we know. But in this way of teaching, the students are the ones that are telling the teacher these rules. Every one of them, the teacher's a true facilitator. Okay, so now students know how to multiply a positive times a negative times a positive, and a positive times a positive. The only one left to try is a negative times a negative. So we're going to use the same types of ideas. So if we begin with 3 times -4, they know how to do this. That's 3 times 4 is 12, and it's a negative. Well, this is one of their rules here. So if I say, okay, if I want the opposite of 3 times -4, or in this case, -3 times -4, what should the answer be? Well, if this is -12, that means the opposite of this should be the opposite of -12, which is +12. Okay, so -3 times -4 equals +12. And I could do another one. I could say, okay, if we had 6 times -3, which we know is -18, then the opposite of 6 times -3 would be +18. And you can see that I could do a third problem, put my data on the board and say, geez, do you see a pattern here? Instead of thinking of it as the opposite and so on, could you just see a way to go from here to here? And the idea is, okay, yeah, you just multiply the numbers, and 2 negatives gives you a positive. Okay, and then we would test it abstractly, and sure enough, the thing's going to work. So now the students have developed these two rules. And you could just leave it like this right here, or you could make it even more general. You could say, geez, if the signs are opposite, the answer is negative. If the signs are the same, the answer is positive. But basically, the students have generated these rules for themselves, okay, through the ideas of groups, through their prior knowledge of multiplication, and what an opposite really means. So we've developed these rules, the students have developed them, and from beginning with the concrete or semi-concrete with the drawings. It's in context. Anytime you're using something like this, it's in context. It's also, we're beginning to reason abstractly here, in that, like in some of these last problems that we were doing, we really weren't using any concrete or even any drawings. We were just looking at, okay, what we know about this abstractly, what we know about the opposite, so the opposite of this, what it should be, all this being done abstractly. So now we're getting to a little bit more sophisticated ways of thinking. Okay, so they're reasoning abstractly. They're looking for patterns. their Bloom's taxonomy is definitely in at least the higher levels of Bloom's are identified here because they are analyzing situations, they're evaluating them, and they are creating rules. So that's the general way to teach multiplication of positive and negative integers.